In this video, I will show you how to convert a decimal number to its binary form. Decimal and binary numbers. As you all know that a binary number contains two digits. One is 0 and another is 1. Since there are two digits in a binary number system, so its base is 2. You can also say it as that the radix is 2. Now, in the decimal number system, there are 10 digits from 0 to 9. That's why its base or radix is 10. And now I am going to show you how to convert a decimal number to its binary form. Suppose you are given a decimal number say 23, and we are going to convert this decimal number to the corresponding binary form, that is in the base 2 form. So the 10 and 2, which is written as the suffix, are the base of the corresponding number system. Let me show you the technique of converting a decimal number to its binary form. Here I will convert this 23, which is in decimal number, is going to be converted in the binary form. For that, first you have to write the 23 over here like this. Now divide this number by the base of the number system where we are going to convert the decimal number. So for here it is base 2. That is, we are going to convert it into the base 2 number system, that is to the binary form. So when there is a conversion from decimal to binary, so you have to divide the number by 2. So when a number is divided by 2, you will get a quotient and the remainder. So we will write the quotient over here and write the remainder just beside it. Now again divide the quotient by 2 and write the remainder beside it. And keep on dividing the quotient until the quotient becomes less than 2. Now 2 multiply 2, it will be 4. So 5 minus 4, it will be 1. Again divide this 2 by 2. 2 multiply 1, 2, and it will give you a remainder 0. Now look, the remainder becomes less than 2. So just stop the division. Now from bottom to top, extract all the remainder and write it from left to right. So the bottommost one will be written as the first digit of the binary system. Then this 0. Then this 1. Then 1. Then 1. So this is the binary form of 23. Again I am repeating, so when there is a conversion from a decimal number to the corresponding binary form, so what you have to do, divide the decimal number by the base of the number system to where you are going to convert the number. That's mean for here it is 2. So keep on dividing this number and write the remainder side by side. So when the quotient becomes 1, that is less than 2, just stop the division and from bottom to top extract all the remainder and write from left to right, and you will get the corresponding binary form of the given integer. Let me take another example where there is a decimal fraction is present. That's mean the given decimal number has an integer part and a decimal fraction part. So how you will convert this number to the corresponding binary form? For the integer part, the rules is same. That's mean you have to write this 23 and keep on dividing by 2. So 2 will multiply 11, it will give you 22, the remainder is 1. Again 2 multiply 5, 10, and the remainder will be 1. Again 2 multiply 2, it is 4, so 5 minus 4, the remainder is 1. Again 2 multiply 1 and the remainder will be 0. And from bottom to top extract all the remainder and write it down as 1 0 1 1 1. And since there is a point after the decimal number, so give a point after this binary equivalent of the integer part. Now for the second half of the decimal number, that is 0.75, for that you have to write like this, 0.75, write it down like this and multiply this number with 2 and the result will be 1.50. Ignore this integer portion and write down the remaining fractional part, that is 0.50. Again multiply this with 2 and you will get 1.00. Here the integer portion is again 1. Now look, here the fractional part becomes 0. So if you multiply this fractional part with 2, it will again give you a 0. So just stop. So whenever you are getting all zeros at the fractional part, just stop it. And if there are non-zero at the fractional part, keep on multiplying with 2. Ignore the integer part, again write down the fractional part, again multiply it with 2. And if it is leads to non-ending, just do 4 or 5 steps. That is enough for you. But in this example, here we get 2 steps. And after that, the fractional parts become 0. Now, this one has been ignored. And this time, from top to bottom, consider the integer part, that is this one. So write down this one at the fractional part of the binary. Again, there is another one which we have ignored during multiplication. So write down this one at the side of the final binary representation. So whatever the integer portion we have ignored, from top to bottom, you have to write from left to right after this point. Close the bracket, and this is the complete binary form of 23.75. So this is the technique of converting a decimal number to the binary form. Let me take another example. Suppose a decimal number 5.15 is given to you, and you have to convert this number to its corresponding binary form. So for that, you have to convert the 5 first. What we will do, we will divide this 5 by 2. So 2 multiplied to 4 and the remainder is 1. Again 2 multiply 1, it will be 2 and the remainder will be 0. And so the binary representation of 5 will be 101. And what will be about the decimal fractional part? So let me write down this decimal fractional part as 0.15, and it will be multiplied with 2. So it will give 0.30. Now this time we will ignore this integer portion and I will write 30. Again multiply this 0.30 with 2, we will get 0.60. So we will ignore this integer portion and I will write 0.60. Again multiply 2, so it will give you 1.20. So this time we are going to ignore this one, that is the integer portion. Now let me multiply 0.20 with 2. It will give 0.40. Again ignore the integer portion of the result, so we have to consider only the 0.40. Multiply 2, again it will give me 0.80. Now ignore this 0. 0.80 multiply 2, it will give me 1.60. So we will ignore this 1. So just stop over here. So here we understand that the process will never end. So in that scenario, we will just stop after 4 or 5 evaluation. And what to do now? Now consider all the integer portion that we have ignored from beginning, and we have to consider it from top to bottom and write it down from left to right after this point. So the first is 0, then 0, 1, 0, 0, 1. So write it down over here, 0, 0, 1, 0, 0, 1. And this will be the complete binary form of 5.15. Since I have taken the approximate binary values of 0.15, so if you convert this binary number to the decimal, you will never get 0.15. You will get a number which is very nearer to 0.15. But this is the technique of converting a decimal number to binary conversion. Hope you have understood the process. Still, if you have any problem, write it down in the comment box. I will try to reply you back as soon as possible. Thank you.